Other than z being either on the circle or within the circle, now argument of z must also be between 0 to 1 over 4 pi. I can reinterpret this by rewriting it as argument of z minus 0 plus 0I must be between 0 and 1/4 pi, which means that we are looking at any point that is here with reference to the origin 0, 0, and the angle that that line is going to make is going to be between 0 to 1 over 4 pi. So where is this 1 over 4 pi? This is the x-coordinate, here is 2, here is 2. So at this point that is just below the circle, this point here is going to be 2 and 2. So if I were to join here to this point on the circle, this angle here is going to be 1/4 pi. And z has to be argument of z minus 0 plus 0I has to be between 0 to 1 over 4 pi, which means that if I were to extend this line, z has to be within somewhere that is here, and yet it has to be within the circle, so z is now going to be somewhere here. And what we want to do is to find the maximum possible of modulus of z minus 6 minus I, which can be rewritten as z minus 6 plus I. That means we are trying to reference any point that is here to the point 6 plus I. Let's say 6 plus I is here, 6 and 1. It is just from here to any point that is here. And how do we get the maximum possible of that distance? And to do that, right, from observation, I know, okay, it is only two possible points. One point is going to be from here to here. Another possible point must be from here to here in order for us to give the maximum possible distance, which is maximum possible of modulus z minus 6 minus I. So I'm just going to find these two distances, okay, and see which one is the bigger one, and that is going to be the maximum possible. To find these two distances is actually quite easy because I can try to reinterpret this entire loci into its Cartesian form. This is a line that passes through the origin and it has an angle of 1/4 pi, which means that the Cartesian equation of this line is y is equal to x. This is a circle with the center at 2, 5 and the radius is 3. That means the equation of this circle must be x minus 2 square plus y minus 5 square is equal to 3. So if I were to quote these two equations, so x minus 2 square plus y minus 5 square is equal to 3, I'm going to call this equation number 1. And y is equal to x, I'm going to call this equation number 2. I'm going to just put equation number 2 into equation number 1. So what I'll have is x minus 2 square plus x minus 5 square. This is equal to 3. If I were to expand and simplify, I'm going to get 2x squared minus 14x plus 20 is equal to 0. And factorizing this using my calculator, I can get x to be either 5 or x to be either 2. When x is equal to 5, that means y is equal to 5. And when x is equal to 2, that means y is equal to 2. So we are looking at 2 points. One of the point is going to be 5, 5. The other point is going to be 2, 2. So here is 2, 2. Here is, let's say, 5, 5. We just need to find the distances between this and this. Let's say I call this distance here h and I call this distance here k. So h is going to be just square root of 2 minus 6 square plus 2 minus 1 square. And this is equal to square root of 17. And k is square root of 5 minus 6 square plus 5 minus 1 square. And this is also square root of 17, which means that these two distances here, both of them are going to represent the maximum possible modulus of z minus 6 minus I. So what I can say is that the maximum possible of modulus z minus 6 minus I, this is going to be equal to square root of 17. And the question wants us to indicate on our diagram here the 2 points that are going to correspond to the maximum possible of this, and the 2 points are this. So this is point P, and here is also our another point P.